All right, so we're going to review for the fourth test of the second quarter. That's going to be on January 10th. For number 1 and 2, we have old radical stuff. Okay, so number 1 is a square root. So you have to see what's the largest perfect square that goes into 243. That would end up being 81 times 3. And the square root of 81 is 9. You still have the square root of 3. Leave some room for your letters. This is a square root, so this number here is a 2. 2 goes into 8 4 times, no remainder, so no x in the radical. 2 goes into 13 6 times with a remainder of 1. And then 2 goes into 5 for z, twice, not 4 times, twice with a remainder of 1. For number 2, we have to see now a perfect the cube root. So we have to see what's the largest perfect cube that goes into 162. That would be 27 times 6. The cube root of 27 is 3. You still have the cube root of 6. And now 3 for the variables. 3 goes into 9 3 times with no remainder. 3 goes into 13 4 times with a remainder of 1. 3 does not go into 2 at all, so z squared stays inside here. Numbers 3 and 4, I asked you to rationalize the denominator. So number 3 is a monomial denominator. So to get rid of the radical in the bottom, you multiply the top and the bottom by that radical. Because now you have 5 times the square root of 10 divided by the square root of 10 times the square root of 10 is the square root of 100, which is really just 10. And then you can just clean up this fraction here. You can't clean up the square root of 10 at all, but you can do 5 divided by 10 is really 1 square root 10 over 2. For number 4, to get rid of the binomial, you multiply the top and the bottom by the conjugate. So you're going to multiply the top and the bottom by 2 plus the square root of 2. By 2 plus the square root of 2. So the top, you distribute. This is now 6 plus 3 square root 2 divided by. On the bottom, if you want, you can double distribute. When you multiply the conjugates, the middle term is going to cancel out and the square root is going to cancel out. So you can just type the bottom part into the calculator. If you type in 2 minus the square root of 2 times 2 plus the square root of 2 into your calculator, it'll give you 2. Okay? So really what this turns into is 2 times 2 is 4. The 2 in the middle are going to cancel out, and then you have minus the square root of 2 times the square root of 2 is 2. So really your answer is 6 plus 3 square root 2 divided by 2. There's nothing else for me to clean up here. If you wanted to rewrite this as 3 plus 3 square root 2 over 2, you can. If you really wanted to do that 6 divided by 2 part. For number 5, rewrite the expressions in simplest radical form. So for number 5, this is asking you for the cube root. So put it in radical form first. The cube root of 27 x to the 10th y to the negative 6th, all then squared. So I'm going to clean up the cube root first. So the cube root of 27 is 3. That's a perfect cube, so no more radical for that. And then for the x's, 3 goes into 10 3 times with the remainder of 1. So I do need the radical for the x's. And then for the y's, 3 goes into negative 6 negative 2 times. And then I have to square everything. So 3 squared is 9. X to the third squared is x to the 6th. That's power to power. Y to the negative 2nd squared is y to the negative 4th. And then x squared is x squared. So I have to look for 2 things. One of them I have to check to see if I can clean up the cube root at all, which I can't because 3 doesn't go into 2 at all. And then the other thing, I have this negative exponent here. Negative exponents, remember, they flip what side of the fraction bar they're on. So my final answer is going to be 9x to the 6th times the cube root of x squared divided by y to the 4th as my final answer. For number 6, we're going to do the same thing we have the square root. You could do this different ways. If you wanted to turn this into 5 over 2 is really 2.5. So if you wanted to do that whole thing in the parentheses squared, and then times, and then the whole thing in the parentheses to the 1/2 power, or really the square root of all of it, you could do that as well. So this would be 12, x to the negative 16th, y to the negative 10th, raised to the 5th power. Again, the rule is power over root. So then for the square root of this, the square root of 12, that is 4 times 3. So that'll be 2 square root 3. Again, whenever we're done, we're going to raise everything to the 5th power. And then 2 here, right, this 2 goes into negative 16, negative 8 times. It goes into negative 10, negative 5 times. And then I raise everything to the 5th power. 2 to the 5th is 32. Then we have x to the negative 40th, y to the negative 25th. Square root of 3 to the 5th is 243. And then I have to just clean this up a little bit. So I'm going to do the square root of 243 first. So the square root of 243, that is 81 times 3. The square root of 81 is 9 square root 3. So if I multiply 32 by 9, that gives me 288 x to the negative 4th, negative 40th, y to the negative 25th, times the square root of 3. And then I just have these two negative exponents here. So my final answer is 288 square root of 3 divided by x to the positive 40th, y to the positive 25th. Again, you could have gotten there by doing different things. Number 7, we have fractional exponent equations. So first I'm going to subtract the 15 and then divide by 7. When I subtract the 15, I get 56, and then divided by 7, I get 8. So right now I have 2x raised to the 3/4 power equals 8. To get rid of that 3/4 power, I raise both sides to the 4/3. So these cancel. Over here, this turns into just 2x equals, because my denominator is a 3, it is odd, I don't have to worry about that plus and minus thing. So really I'm doing the cube root of 8 to the 4th power. If you do it right in the calculator, it'll give you 16. Divide by 2, you get x is equal to 8. Check your answer, and that is in fact it. For number 8, I'm going to subtract the 9, divide by 3. After I subtract 9 and divide by 3, this is x minus 1 raised to the 2/3 is equal to 21 minus 9 would give me 12. 12 divided by 3 would give me 4. So then I raise both sides to the reciprocal, which would be 3/2. This will cancel over here, and I get x minus 1 equals. Because on the right side, I'm raising 4 to the 3/2, I'm really doing the square root of 4, which would give me a plus and minus because my denominator is even. I'm doing an even root. So the square root of 4 cubed would give me 8. So I have x minus 1 equals 8, and x minus 1 equals negative 8. This side gives me x equals 7. This side gives me x equals, this gives me 9. This gives me negative 7. 9 and negative 7, you plug them both back in, and they both do in fact work out. And then number 9, you're going to add 1 to the other side. So the square root of x plus 43 is equal to x plus 1. If you wanted to rewrite this square root as the 1/2 power, you can. I know you guys know that the inverse of a square root is to square it. So I know you're going to know that you raise both sides to the 2nd power. This will cancel over here. You get x plus 43. On the right side, you have to do x plus 1 times x plus 1, which gives you x squared plus 2x plus 1. Set it equal to 0, so I'm going to subtract the x and the 43 over, which gives me x squared plus x, and then minus 42. Some of us, I've been noticing, have been doing weird things with master product lately. I don't know if it's because we're trying to go straight to the answer or what it is. I want you to go through and do master product. All right, so two numbers that multiply to be negative 42 and add to be this positive 1 are positive 7x and negative 6x. Split it down the middle, x times x plus 7 minus 6 times x plus 7, which gives me x plus 7 times x minus 6. So my two possible answers, right, because this is equal to 0, are x equals negative 7 and x equals positive 6. I plug them both back in, and I see that x equals negative 7 gets rejected, so that's not my answer. Numbers 10 and 11, we have exponential equations. Neither one of them have common bases. So first what I'm going to do, I'm going to rewrite this 1 over 216 as 216 to the negative first power. So now I always try to go smaller. So I look at the 36 first. 36 to the second power does not give me 216. It's way too big. So then I have to go smaller. So the base that I know that I'm going to be able to get with a 36 is that 36 is 6 to the second power raised to the 2x minus 15. And then 216 is 6 to the third power. But because this was a negative 1, this is going to be negative third power, right? 6 to the third is 216. 6 to the negative third is 1 over 216, which is what I want. So now power to power we would multiply. So this equation is going to be 4x minus 30 equals negative 24 plus 12x. This would give me 8x over here. And on the other side, this would give me a 6, negative 6. So then when I divide by 8, I end up getting x is equal to negative 3 over 4. Plug it back in, and it does, in fact, work. Okay? And then number 11. We have 1/5. I'm going to rewrite this as 5 to the negative first, raised to the negative 2x squared minus 4, equals 125 is 5 to the third, raised to the 10x minus 32. So then my equation, power to power again, you multiply, would be positive 2x squared plus 4 equals 30x minus 96. This is a quadratic equation. 2x squared minus 30x plus 100 equals 0. You could take out a 2 to make it a little bit smaller numbers. If you want, you don't have to. Two numbers that multiply to be 50 add to be negative 15 are negative 5 and negative 10. When I split it, this is x minus 5, minus 10, x minus 5. So x minus 5 times x minus 10 equals 0. And then I do my t-chart, which gives me x is equal to 5 and x is equal to 10. I know x equals 10 gives you an overflow error. That just means that the numbers are too big, but it does end up give you the same really, really big number. That wouldn't happen on a test. Okay, you would actually be able to plug it in and check to make sure it's the same number. Number 12. So pretty much all of this from here down is old stuff. Number 12, we have the focus and the directrix. So again, if you graph this, 4, 0 is right here. Y equals negative 6 is right here. The point that's in the middle of them, that's your vertex. So that point is right here, which is 4, comma, negative 3. Your parabola is concave up, because again, the parabola has to hug the focus, which means P is a positive number. You are going up 3 to get to the focus. So your equation, x minus h squared equals 4p y minus k, is x minus 4 squared equals positive 12y plus 3. For number 13, state the intervals of increasing and decreasing. So you're going to plug this equation into y equals. I suggest you just draw a little graph of it quick, nothing exact, just a quick sketch. And then in order for you to find the intervals of increasing and decreasing, you need to find the mins and the maxes because those are your turning points. You don't really need to find the entire min and max, you just need the x values. It's just the x values only for the mins and maxes. So for this max, you would do second trace number 4, it says maximum. That's when you do that left bound and right bound stuff. So this gives me, I told you in class to round to the nearest thousandth. This is x equals negative 2.897. And then the minimum is 0.230. Again, and to find the minimum, you would do second trace number 3 instead of number 4. I also gave you the other tool that would make this helpful is to draw a number line just to kind of graph it out. You have two relative extrema. One is x equals negative 2.897. And the other is at 0.230. So from negative infinity until negative 2.897, right here, negative infinity up until here, you are increasing. And then from negative 2.897 until that 0.23 number, you are going down, you are decreasing. And then you change direction for a final time at 2.320 until infinity, you are increasing. So then you have to then change this into the interval though. You can't leave that as your answer. So you would have to write increasing from negative infinity, negative 2.897. And again, so you put a u from 0.230 until infinity. And then decreasing would be negative 2.897 until 0.230. It comes right off of your number line, okay? Your number line can't be your answer, but that does help kind of organize the information. Okay, number 14 is the inverse function. You guys, I put this on here because it was on your last test, and I know we had a few issues with it. So inverse is when you switch the x and the y value. So I have x equals 3y minus 2 divided by y plus 4. So I know you know what an inverse is because a lot of you had at least this written on your paper, but then from here you didn't know how to get y by itself. So you are going to cross multiply. So you get 3y minus 2 equals xy plus 4x. Then you're going to bring all of your y's to one side, anything without a y to the other. So I'm going to subtract the xy and bring it to the left and add the 2 to bring it to the right. Now on the left, the problem is that I still have two y's. I can't combine them because they're still not like terms. But what I can do is take out a GCF of y, and I'm left with 3 minus x. This side stays the same, and then you can see what you have to do. You would have to divide by 3 minus x. So y would be equal to divided by 3 minus x. This would still, if this is short answer, you would still lose credit though because I asked you for this. So you have to write it in this notation. 4x plus 2 over 3 minus x. Okay. Number 15, a circle-linear system of equations. So this here is the line, and this is the circle. So I'm going to, it doesn't matter really if you look at what I have in that box. It doesn't matter which variable you solve for. I am going to just solve for y is equal to negative x minus 1. I'm going to then take this negative x minus 1, right? That's what y is. And I'm going to plug it in for y right here. So now I have this. I have x minus 3 squared plus negative x minus 1 plus 2 squared equals 34. So this is x minus 3 times x minus 3 plus negative x plus 1. I'm combining these two. Negative x plus 1 times negative x plus 1 equals 34. So this is x squared minus 6x plus 9 plus x squared minus 2x plus 1 equals 34. It's a quadratic equation, so I'm going to combine like terms and bring that 34 over, which gives me 2x squared minus 8x, and then I would get 10 minus 34 is negative 24 equals 0. I'm going to divide everything by 2. If I factor this, I would end up with x minus 6 times x plus 2 equals 0, which gives me x is equal to 6 and x is equal to negative 2. I'm not done yet though, because again, the answer to systems, I need coordinates. So my y values, y is equal to negative x minus 1. So negative x minus 1 gives me negative 7. So one of my solutions is 6 comma negative 7. The other one, y is equal to negative x minus 1. The other one is negative 2 comma 1. And last one, number 16, I told you I want you to know how to do it algebraically. I'm going to just cross out this number 16, that way I don't get confused with my numbering. I'm going to eliminate my z's. So in equation 1 and equation 2, I would multiply the top equation by negative 4. So this is now negative 4x plus 24y plus 4z equals 32. The bottom one is 7x. This stays the same. 9y minus 4z equals negative 8. I add down. This gives me 3x plus 33y. My z's cancel like they're supposed to. Equals 24. That is equation A. Equation B. I'm going to do elimination on 1 and 3. So I have to get rid of z again. So I'm just going to multiply the top equation by 2. Because this gives me negative 2z, and on the bottom of that I have a positive 2z. So when I add down, that gives me 4x minus 11y, that cancels, and I get equals negative 23. That is equation B. So now I need to do elimination on A and B. So if I multiply B by 3, that's equation A. If I multiply B by 3, I have 12x minus 33y equals negative 69. I add down. This gives me 15x. My y's will cancel. 24 minus 69 is negative 45. Divided by 15 gives me x is equal to negative 3. So now I work backwards once I have 1. So I have 3 times x plus 33y equals 24. So this would be negative 9. So I add the 9 over. I get 33y equals 33, which means y is equal to 1. So I have x, I have y, I plug it into one of the originals. So x minus 6y minus z equals negative 8. This would be negative 9 minus z equals negative 8. And then I add the 9, negative z is equal to 1, z is equal to negative 1. So my answer, negative 3, comma 1, comma negative 1. Make sure you can plug that into your calculator without having to do it algebraically, just so you can check your answer, or save you some time if this is ever a multiple choice question. Okay, extra help will be on Thursday after school if you still have any questions. Have a good night.